Yes, my name is Ira, and I will be walking you through briefly about my data modeling lab project using third normal form in Docker and PostgreSQL. So the school, wait, so the school, which is a vocational school, wanted a database that will directly fulfill its business requirements, which is actually available in my documentation. And it wanted the daily operations to be supported, such as managing the students, the enrollment, the courses, the classes, academic rules, and the staff. And the staff also includes the instructors and the program managers. So, to be able to achieve this, after talking with the school stakeholder, I created the conceptual and then the logical and then to the physical model. And then I made sure that it was a third normal form, and then I deployed it to PostgreSQL in the Docker container to create a controlled and reproducible and idempotent database environment. So this workflow allows the model to be implemented exactly as I designed, and with constraints and triggers and business rules enforced at the physical level, and tested in expanding the school. So I started with this project with a question in mind, like why is this database existing, and who are the users, who are the end users, and what are the most common queries. So before designing any tables, when it comes to data modeling, it is important to look at how the stakeholder or the school in this case actually operates and what users do on a daily basis. So typical actions include adding students and staff, managing contracts, assigning classes, enrolling students, and updating statuses over time. So the conceptual model represents this business reality that the stakeholders wants. It will show the most important entities in the system and how they are connected without thinking about databases or technical rules yet. So the purpose of this step in the conceptual model is to make sure the model reflects how the school or the business works in real life. And yes, here is my conceptual model for the school. I focus on how the school operates in practice. So I identified the main people involved, who are the students, staff, and consultants. Each student and each student, staff member, and consultant is they are linked to exactly one set of private details, while each set of private details belong to one and only one person. So this avoids duplication and keeps sensitive information very centralized. And then the contracts are modeled separately from people. The reason is because one person can have multiple contracts over time, but each contract belongs to exactly one person and one campus. So this supports the role changes and the status updates and then the historical tracking over time. And then the education structure is built around programs, courses, and classes. So one program can contain many courses, and one course can belong to a program or exist as a standalone course. Classes represent the actual delivery of education and are linked to one campus and optionally one program. And then another entity we have is that students can enroll in classes, which is the enrollment. It's not in here yet, but the students can enroll in classes through an enrollment relationship, which will show in the logical model. So a student can only have one active enrollment at a time, which is provided by the business requirement, and cannot study a program and a standalone course at the same time. So each enrollment always links to one student to one class. And then consultants teach courses through a teaching relationship. So one consultant can teach many courses. Oh, and one and a course can be taught by different consultants over time, depending on the availability. And then the responsibility, project manager management, is modeled here explicitly as a associative table. And a staff member, through a staff contract, can act as a program manager and manage classes. And one project manager can manage a maximum of three classes at the same time, and each class is managed by exactly one program manager. And then finally, the model is designed for future expansion. The school may expand with new campuses, programs, courses, students, staff, or consultants, and so on. And they can change based on the needs and instructor availability. So this model will ensure that the current operation and the long-term scalability. And then here is my logical model. And each conceptual entity becomes a table with a clear responsibility. Um, in the conceptual model, primary keys uniquely identify each record, and foreign keys define how tables are connected. For example, staff, students, and consultant are linked to private details using foreign keys, which ensures that personal information is stored once and reused consistently. Contracts are separated from people and link back using foreign keys. This allows one person to have multiple contracts over time, but only one contract is active. That means if you want to create a new contract, the old contract must be deleted. So you can create many contracts as you want, but it's only one contract at a time. And then that will always belong to exactly one person and one campus. And then education relationships are also made very explicitly. Classes references campuses, and then it can also references the program and the enrollment linked to student to classes, and teaching assignments connect consultants to courses. So these foreign keys will ensure that all relationships follow the valid business rules by the stakeholder, and the model is designed in third normal form, which each table stores only data that depends on its primary key. There is no duplicate information, and non-key attributes do not depend on key other non. Yes, so the database right here is deployed through Docker and PostgreSQL. And through Docker, I can spin up a mini computer of PostgreSQL. And then with a clear separation between schema definition and then, as you can see here in the C data and query logic. So Docker Compose starts the database, and then it automatically runs the initialization scripts from the SQL and then init folder on this first startup. So basically, what I want to show, for example, is that in the ddl.sql file. So the script starts with a create table, if not exist, statements to create all core tables such as a program, campus, uh, companies, consult company, student, staff, course, class, and so on. And then each table maps directly to the logical model and uses primary keys to uniquely identify records for example, like program ID, student ID, and then class ID. And about the not null constraints, so these are the constraints that are used for the required business data. For example, in the program table, the program name and program credits are not null, ensuring that the program cannot exist without a name or a credit value. But however, I also created a one important check constraint here in the check standalone class. So it will enforce that a class can only be standalone if program ID is null, and that right here, and that program classes cannot standalone class. You cannot use standalone class codes using with the SC uh, character right here. So basically, the one that I have shown in my logical model that is a program, if the program ID or program name is null, then basically it will be a standalone class. And this is where I could enforce it using the check and the constraint. Another good example use of check constraints is that it can also enforce valid business values. So example include these program credits is greater than 0. So the valid contract status such as active or if it's ended. And then you also have date rules like end date is greater than or equal to start. And then we also have some business rules that require procedural logic. So for example, the function that I made enforce max 3 classes counts how many classes a program manager is already managing. So if the count is 3 or more, the function raises an exception and then blocks this. So why did I choose to create a DDL.SQL? Well, it's because it defines the full physical schema, including the tables, keys, constraints, indexes, functions, and trigger, and then it is also fully idempotent. And fully idempotent basically means right here that it is good to use because it can separate schema, seed data, and queries, and then it will reduce the risk and makes the system easier to debug and maintain, especially if you are using Docker. And then with the Docker initialization, it will ensure that the database is created the same way every time, which is very important for reproducibility. And then in the idempotent schema scripts, it will prevent accidental errors if the database is initialized more than once. And then lastly, since we have a lot of triggers and constraints, I use constraints where possible and triggers only for business rules that can't be expressed in the entity. Yes, so now I'm in my Docker and I'm just gonna run this 03 queries.sql in Postgres. First query that came out is answering the question that to query all the students, first names, last names, and their contact info, which I derived from the private details table. SQL scripts for this query to be able to answer the the requirements for this lab is available in 03 queries.sql. Who the students are and which classes they belong to and which program that the class represents. So in the logical model right here, we can see that the students enroll in classes, not directly in programs, and they enroll through enrollment. So I will be able to break the many-to-many relationships. So this program is derived through the class. So if we go back here, so I split the results by enrollment status right here. And then I have 9 students that are active, and then 4 students that have graduated, which is 2023, 2025, and then 2 students from one for each program that have withdrawn. For the standalone bonus, we also see that students enrolled in the standalone cohort. Distance cohort is here. So these rows have no program name. These courses, standalone distance cohort, which has a class name, has no program name, which confirms the design choice that the standalone courses are modeled as classes with a null program reference because of the checks and the constraints that I have made. Jumping straight to query number 5, which is the planned employment of permanent instructors. The instructors are right here. This staff contract, staff, and program manager. If you focus on those 3, the instructors are not a separate entity. Instead, the instructor is here inside the staff contract that is a role type. And it is a role defined by the staff contract, which allows the planned, active, or pause employment to be handled through time and status. And this will also fulfill the requirement that planned employment is represented through future dated or non-active contracts. So I start from staff with their first name and last name, and then I join them with the staff ID to staff contract to get the role. And from the staff contract, I can also join them here into campus to show where the contract applies. And then this will also reflect that employment is always tied to a campus, not directly to classes or programs. And this output confirms that we have permanent instructors at both Stockholm and Göteborg. And then going to query number 6, we wanted to know which courses and programs do consultants teach and which campuses. Resolved through the consultant teach as associative table. And then it will link through consultants, from consultant to the course. So the programs are derived from courses, and then a left join is used to support the standalone courses with no program. And as also you can see here, we have Karin Data. She is a consultant and she is teaching a course name called the standalone course. And as you can see, it is not included as a program. Query number 9. I wanted to show that who are the staff that are program managers in all campus and which classes are they in charge of. So going back again to the logical model, the program manager responsibility is modeled through the program manager management associative table, which links a staff contract to a class. So this design will allow me to enforce the business rules at the database level, such as exactly one program manager per class and a maximum of 3 classes per program manager, which is why each manager appears with 3 classes in this result. And then when I tried to query and when I wanted to do an insert to add another class on either of them, it raised a function that I made enforce max 3 classes. The last query that I want to show is that what classes belong to what program. So it is right here. Yes, and lastly, I just want to quickly point out that I have the 04 insert new cohort.sql script that basically it just shows all my insert statements or query I have to check that the new values that I wanted to add in my database have worked. We wanted to add 2 new students named Leah and Emma right here, and then the new program manager Mark, and then these new values will be in the data engineering program for the 2026-2028 cohort.